When somebody says climate change is a hoax, what do they really mean? Let's dive into that. What are the facts and what's being debated now? In this episode, we'll be talking about my learnings and understanding of global warming and climate change that I've acquired over the last 2 to 3 years of research. The intent here is not to convince a denier it's real. It's more for you to understand the real debate that's going on. So I'm going to talk about the undisputed science. I'll talk about natural versus human-driven climate change, and then talk about the disputed areas, which is mostly about the severity of the effects, the long-term aspect of those effects, and talk about the urgency that drives me to action. The first thing is the greenhouse effect, as it's called, has been known for 200 years. Scientists back in the 1800s proved that if there's more carbon dioxide in the atmosphere, that more heat is going to be retained. This was verified experimentally over the last 200 years. So if you look at this first chart, you can see on the left side is the natural greenhouse effect. There is a little bit of carbon dioxide in the atmosphere naturally, and the ultraviolet, the high energy ultraviolet and visible light gets through it. But as it heats the Earth's surface, the infrared light, the lower intensity light that normally gets reflected back, is interfered with the carbon dioxide, and it pushes a little bit that back to the Earth. And it's a good thing it's there, because if we had no carbon dioxide, the Earth will be much, much, much colder than it is today. What's happening on the right side, we're introducing more carbon dioxide, and it increases the amount of energy that is absorbed by the Earth, and the temperature goes up. Nobody disputes this in the scientific community. The second point is carbon dioxide has been increasing in the atmosphere proportionally to the amount of fossil fuels we burned. If you look at the chart here, you can see the blue is the carbon dioxide concentration in the atmosphere. It's been measured directly since 1957. Before that, it can be inferred by little bubbles that are in the ice sheet in the Antarctic. They can measure those and determine what the concentration is. The amount of fossil fuels we burned is fairly well measured around the Earth. And so you can see they correlate pretty well. Nobody disputes that when you burn fossil fuels, you get more carbon dioxide, and nobody disputes that the carbon dioxide concentration is going up. Early on, a few people say, well, maybe it's not a causation, it's just a correlation. They just happen to go up together. And other folks will say, well, maybe one's causing the other. The higher temperature is causing the higher carbon dioxide. Carbon dating technology has basically validated that it is the carbon dioxide from burning the fossil fuels that's increasing the concentration. Again, no real debate here. Then the question comes out, well, there's natural climate change. We have ice ages. Is that causing this, or is it overwhelming it? And a lot of research has gone down here. 200 years ago, geologists in Europe hypothesized that we went through ice ages by examining glaciers. They didn't know why. And then in 1930, an astronomer named Milankovitch theorized that there are changes in the Earth's orbit around the sun based on its interaction with all the other planets, and that the orbit went from a cyclical nature to an elliptical nature. And when it went more elliptical, the sun or the Earth spent more time further away from the sun, and it cooled. Those are ice ages. And he hypothesized this cycle would happen about every 100,000 years. Tough to prove, but paleoclimatologists have developed a tremendous amount of technology to develop what they call proxy temperatures of the past. Just like a tree has rings, ice in the Antarctic has layers, the ocean floor has layers, and there's 20 other of these proxies that they can look and examine and tell about what temperature, the average temperature was during those years. And the nice thing is they all corroborate one another. If you look at the chart here, it shows this data for the last 500,000 years. And you can see there's 5 peaks and 5 valleys. The peaks are interglacial periods where it's warmer, like it is today. The valleys are the ice ages. And so, it basically corroborates this theory there is natural climate change. Well, where are we? If you look at the next chart, this blows up the last 12,000 years. And it shows that we were actually hit a peak about 7,000 years ago. And since then, we've been in a slow decline, heading for the next ice age 50,000 years from now. However, you see at about 150 years ago, all of a sudden that slow decline stopped and we spiked up exactly when fossil fuels started being burned. And so right now we're probably at the highest temperature the Earth has seen since humans existed on Earth. All this has me convinced climate change is real. Fossil fuels are increasing the carbon dioxide concentration, and that is heating the Earth. And if you don't believe me, well, let's talk about Exxon Mobil, one of the largest oil companies in the world. Back in the 60s and 70s, when climate change, global warming first began to get accepted as a theory, of course, it affected their business. So they did a lot of research, both in-house and third-party research, to try to see, is it real, and are there other potential causes for the carbon dioxide increase and the temperature increase. Finally, in 2014, with all the data and everything pretty much overwhelming, they admitted publicly that, climate change is real. It's caused by fossil fuel burning. If you click on their website, which we have a link here, you can see the very front page. It's in their mission about emissions reduction. They've got carbon capture, and most of the articles on that front page are around approaches to battle climate change. So what's the debate? There's still a huge debate, mostly around how quickly will the surface temperature increase in the world. And that depends on how many emissions we continue to put up there. China's putting more solar, nuclear, and wind capacity in than the whole rest of the world. When will that catch on? There's a lot of factors that are difficult to predict in the models. An example would be the ice sheets. They're large right now. They are shrinking, and an ice sheet is white. It reflects heat right back into space. But when that melts, that surface shrinks and it becomes ocean and land. Both of those absorb the radiation from the sun much more effectively. You've heard of permafrost. This is organic material that's been frozen since the last ice age. Well, if that keeps melting and gets exposed, that organic material decays and increases the amount of carbon dioxide. So there's a lot of uncertainty on how quickly the temperature will rise. And then a lot of uncertainty say, so what? What happens? Sea rise. Yeah, sea's been rising for 25,000 years. It's believed that 15,000 years ago, the Bering Strait up near Alaska wasn't covered by ocean. And humans walked across, and that's where they first migrated to North America. So it's been rising for 25,000 years. It'll continue to rise until we start to get down into the next ice age. But with this human-caused increase, it's going to accelerate. How quickly? Pretty tough to predict. Intense storms. Yeah. The warmer the ocean is, the warmer the air is, the more water is going to go up and cause a lot more flooding. How much? You can debate that for a long time, till the cows come home. And talking about the cows coming home, I believe that's going to be the biggest impact is around agriculture. As the climate changes, different crops can't survive in that heat. And in the United States, it's probably not as big of an issue because we can move north all the way up into Canada if we have to. But just think about island nations and sub-Saharan Africa where there's subsistence farmers. They depend on that food to live. So there's going to be a lot of change and a lot of debate on what happens, and you just don't have absolute certainty there. So that's going to be debated for quite a while. On the other side of the coin, you'll have people like the director of the EPA, where he testified before Congress. Yeah, climate change is real, but will play down the potential effects and can say some people are exaggerating, and that's true. There's the Chicken Little effect, where, hey, humans are no longer exist, the earth is going to be destroyed. To me, that goes way too far. If you look at the amount of fossil fuel there is to burn, even if we burned that all, the planet's still going to survive. A lot of plants and animals will not be able to survive because they can't migrate, they can't evolve quick enough to adapt to that. Humans have the technology to do that. Huge disruptions, but people can go north. You still can grow crops further up there. Humans will survive. Enormous amount of people will perish, but humankind will survive, and the earth will survive. 50,000 years from now, I believe we will be back in an ice age, that this couple thousand-year blip in glacial time, will be overcome, but there'll be an enormous price to pay. One last point that I did want to make is, I made it in the opening episode, is the longevity and the long-term issue we're dealing with. And this has to do with what we call the carbon cycle. Carbon moves around a lot in the surface, and everything starts with the sun and photosynthesis. If you look at this chart on the left side, carbon dioxide and sun are used by plants to produce organic material. And that organic material is basically the fuel for all energy, except for nuclear, all energy that we see and use today. When those trees die and those plants or the leaves come off, microorganisms use that energy, decompose it, and use that energy for their purposes, and it emits carbon dioxide. Animals do the same thing. Trees actually do the same thing, called respiration. They make their own organic material, but they also take in oxygen, break it down, use that energy for different purposes. So almost all of that carbon dioxide that's brought from the atmosphere into organic material eventually decomposes one way or the other and returns. However, there's a small amount, you see the very bottom of this cycle, that it gets buried in the bottom of swamps, the bottom of the ocean, but it's not exposed to oxygen, so it doesn't decompose. And then it gets sucked down into the earth, and over millions of years with pressure and temperature, it becomes fossil fuels. The problem is it's a very slow process. And we are, you see the right side, through burning, heating our homes, using electricity, driving our cars, we're taking that fossil fuel that's been down there being generated for millions of years and accelerating the way it comes into the atmosphere. So when you look at this cycle, we put it out very fast, but it gets sucked in very slowly. So every pound of carbon dioxide we emit today, we as people, we as a society, is going to be around for a long time. The scientists estimate that if you burn it today, half of what you burn, the carbon dioxide, will still be around 50 years from now. And it'll take hundreds, if not thousands of years to remove it all. So we're looking at a very, very long-term issue here. So when you sit back and you say, hey, should I put up solar panels? Next time my air conditioner is getting old, do I replace it with a heat pump? Or next time I need a car, do I replace it with the electric vehicle? Think about that. And that's what our whole offering is, to take a look at these things and what's best for your wallet to do, but also what's best for the world. And every one of these technologies that you invest in increases its ability to improve and serve the entire world. Thank you for watching Fade Your Footprint, a show about home decarbonization. Make sure you visit my website, fadeyourfootprint.org, and check out my free tools or book a free Zoom session with me to take steps toward reducing your personal carbon emissions.